Example 1 here on the R addition formulae is being able to convert with R formulae. And what we're asked to do here is express 8 sin x plus 6 cos x in the form R sin x plus alpha. Now here what we're going to do first is assign R sin alpha and R cos alpha as the appropriate values. And in this case R sin alpha will simply be 6 and R cos alpha will simply be 8. Okay, so now we've assigned the appropriate values here, what we need to do is we need to work out R, we need to work out alpha. Now to work out R, we can simply do this, working out R squared first, which is equal to R squared times by sin squared alpha plus cos squared alpha. Well, in this case, if we expand this bracket here, we obtain R squared sin squared alpha, and then we're going to obtain R squared cos squared alpha. Now here, if we were to take R squared sin squared alpha, this would just be R sin alpha squared. So in that case, all we need to do here is simply replace this with 6 squared, that's R sin alpha squared, and do the same here with R squared cos squared alpha. If we square this side here to obtain R squared cos squared alpha, then we just need to square this side as well, which gives us 8 squared. And if we work this out here, this gives us 100. So what we're saying is R squared is equal to 100, so therefore R is simply the square root here, and this value must be positive, so we only take the positive solution, giving us 10. And now that we've got R, we can simply work out alpha here by doing tan inverse of tan alpha. Now tan alpha, we can express that in a slightly different form here using our identities. We can write this as tan inverse of R sin alpha over R cos alpha. Now here, R sin alpha we know is just 6 and R cos alpha is just 8. So therefore, for alpha here, we're looking to just find tan inverse of 6 over 8. And remember, when you're working this out now, just be slightly careful. Our solution must be in degrees. So therefore, alpha is just simply tan inverse of 6 over 8, giving us 36.87 degrees. And if we write our answer now in the form that's asked of us here, we can write 8 sin x plus 6 cos x in the form here of 10 for our value here, sin x plus 36.87 degrees there. And that gives us the solution to example 1. Example 2 here on the R addition formulae is converting with R formulae again. Again, this is going to look quite familiar. We're just expressing 8 sin x plus 6 cos x in the form R cos x minus alpha, okay, where alpha is between 0 degrees and 9 degrees. So to start with here, let R sin alpha, so let R sin alpha be equal to 8, okay? And if R sin alpha is equal to 8, then that means R cos alpha is equal to 6, okay? Now the first thing we want to find here is R. And to find R, we can make use of the fact that R squared can be simply expressed as R squared times by sin squared alpha plus cos squared alpha. Okay. Well, in this case here, we can expand this bracket here with R squared to obtain R squared sin squared alpha plus R squared cos squared alpha. Okay. Well, in this case here, for example, R squared sin squared alpha is just the same as squaring this expression here. R sin alpha squared would give us R squared sin squared alpha, so in that case we just need to square the right hand side here. So that's simply equal to 8 squared plus R squared cos squared alpha, and again that's just the same as squaring this left hand side here, so we just do the same to the right hand side. So that's 6 squared there. Okay, so this is for R squared here. Well, in that case here, 8 squared is 64 plus 6 squared, which is 36, giving us 100. And we just simply want r, so therefore we're just going to take the square root here to obtain that r is equal to the square root of 100, which simply gives us 10. So we've obtained the value of r here. Now we just need to obtain the value of alpha. Okay, and note first that we're working in degrees here. Now if we want alpha here, so we want alpha, well, what we can do here is simply find tan inverse of tan alpha. Okay, so tan inverse of tan alpha. And tan alpha, we can simply express that as r sine alpha over r cos alpha using our trig identities. So in that case, alpha simply equal to tan inverse of r sine alpha over r cos alpha. Okay. Well, in this case here, r sine alpha is 8, r cos alpha is 6. So all we're going to do here is simply find tan inverse of r sine alpha, which is 8, over r cos alpha, which is 6 here. So we need to find tan inverse of 8 over 6, ensuring that we're working in degrees here. And what we'll find here for alpha is tan inverse of 8 over 6, giving us 53.13 degrees there. Okay. So in that case now, all we simply need to do here is express a sin x plus 6 cos x in this form here. So therefore, we write that at the bottom here, a sin x plus 6 cos x simply equal here to 10, because that's what our value of r is here. So that's 10 cos x minus alpha, where alpha is 53.13 degrees there. Okay, and that gives us the solution to example 2 there.